Now let's adjust the configuration on the receiving server. In shell number 2, we have a session open to Linux CBT work 1. In fact, let's just rename this session so that it's obvious. Linux CBT work 1. This server is what we're considering to be the inside server. We're going to make changes to the main.cf file to instruct our server to handle messages destined to the domains linuxcbt.internal, or external that is, as well as Linux computer-based training.internal, as well as .external. So let's nano main.cf. We'll find the my destination parameter, and here it is. Now the reason why we're defining these particular domains as part of the my destination directive or variable is because we're considering the SUSE professional box to be the termination point for these domains that we're defining on the enterprise server as transport maps. Let's rename the session here. This is Linux CBT SUSE serve 1. So since we're considering work 1 to be the destination or the termination point for these or for the domains that we've just created, we need to use the my destination directive because postfix understands the my destination directive to be domains that are considered local. So we'll simply append to this list, and we'll append linuxcbt.external. We'll also append Linux computer-based training.internal, followed by Linux computer-based training.external. So all these domains are handled. Now we can separate these items on a different line by just starting the new line with a space, or we can keep them all on one line. Either or will work. These are all considered separate domains. They are separate domains, and for that matter, you can treat these as virtual domains. But this form of virtual domain assumes that all users that are considered local to the Linux CBT work 1 box will have email addresses automatically defined as the local username, which is defined in etc password by default, at all of the domain names specified. So this isn't the ideal way to implement virtual domains for most environments, but for some it is. For some corporate environments, you may want all users to have email addresses that terminate in all domain names that are owned by the company. Super. So now my destination recognizes all these domains. We will route messages into the local system based on those domains. On the remote system, we'll execute a postfix, reload of course. This refreshes the postfix mail system. Now back to the SUSE enterprise system. We can generate a message from here or from the internet, which will terminate or be routed through the SUSE enterprise system to be terminated further on the Linux CBT work 1 box. Either or. If we generate the message here, we avoid having to go out to the internet to discover who's responsible for Linux CBT.external as well as for the other two domains, which wouldn't exist on the internet anyway since they're invalid suffixes. So to keep it simple, let's launch mutt. We'll generate a new message. We'll send it to root at linuxcbt.external. Subject, testing, transport maps, and we'll ignore the body as we tend to do to save time. Notice no bounces. I'm moving the arrow keys up and down. No bounces. On the remote system, Linux CBT work 1, we can launch mutt to see whether or not we've received the message. And here's the message, testing transport maps. So we've received the message to linuxcbt.external, to the user at linuxcbt.external. Again, as I mentioned, with respect to virtual domains, this pertains to all users on the system. So if we compose a new message destined to a different user, such as Linux CBT SUSE 1, let's exit this shell. We'll SSH into Linux CBT work 1 as the said user. .Linux CBT internal. We'll authenticate. And now we're on the system. So we're set to receive a message. Now we'll just copy the message from the shell prompt to save us from typing, and back to Linux CBT SUSE serve 1. Let's generate a new message to the user. We'll use Shift Insert to paste the email address. Testing to a different user. And that message was also sent. So in shell number 3, a launch of MUT will show the new message plus older messages. Testing to a different user. So again, it is a form of virtual domains. May not be ideal for your environment, but you get the picture. Now let's send a message to root at Linux computer base training.internal. Testing transport map number 2. We'll ignore the body. Let's add a CC recipient of Linux CBT SUSE 1 at Linux computer base training.external. So we're sending to both transport maps, or transport maps number 2 and 3. We'll send it, and this message was delivered, no bounces. So in both windows we should have new messages. There's the new message to root at Linux computer base training.internal, and the message was CC'd to Linux CBT SUSE 1 at the external domain, which means in shell number 3 an arrow key up will show the next message. So the transport maps are up and running, but again, let's just examine the configuration on the receiving mail server's setup. Its setup is as follows. Postconf grep my destination echoes that the receiving server, the destination server, your internal box, which may or may not be running postfix, but since we're examining postfix, we're assuming that you are running postfix, is configured to receive messages or to route messages locally to the following domains. My destination gets routed locally. By default, its transport map is configured to deliver the messages locally. And the transport maps the transport map for local delivery is defined also in main.cf, and the actual transport's defined in the master.cf file. So any domain that matches the my destination directive or variable will get routed locally, which means the user part needs to exist in the local system configuration database for the users, whether it's the etc password file or another repository such as LDAP, MySQL, and so on. On the gateway, however, we simply set up transport maps using the transport mapping type. And in there, we define the domains that we're interested in routing and the transport followed by next hop directive, which is the way you specify the right-hand side. Now you can avoid specifying the right-hand side, which would force postfix to perform name lookup, name resolution, but then that sort of defeats the purpose of having the transport map, since you could simply enter the domains into the relay domains anyway, because these domains that you're going to relay need to exist in your relay_domains single column file, which gets converted into a database format anyway. So if you intend to ignore the right-hand side, which directs traffic based on the domain, or on the left-hand side, domain, user, subdomain, and so on, then just don't define that particular entry in your transport file, or avoid defining it in your transport file. The transport file again is used for directing traffic based on the left-hand side. Now we've shown you an example of mapping the left-hand side to various domains. These are various second-level domains. You could also, again, specify an individual user. Let's say you have a user such as root at a certain domain. You'd like to have it forwarded to a different host, but all the other email addresses be forwarded using normal MX lookups, or even to a different host. That's where the transport table would help you. So you could have one entry. Let's say, for example, let's modify the transport, or just show you how you do it. Let's say you want all messages destined to abuse at linuxcbt.external to be forwarded not to Linux CBT Work 1, but to a different system for consolidation purposes. Perhaps you'd like to have messages sent to the abuse user, so it would make sense to list this particular entry first. But then all other users at linuxcbt.external would be forwarded to Linux CBT Work 1. Or you may just want to configure a one-off for a totally different user. Left-hand side maps to the transport and next hop on the right-hand side. But generally, for most corporate environments, you'll have simple setups which will determine where the messages are routed based on the left-hand side, which usually is based on a given domain being sent to a given server or to a given name, which may or may not equate to multiple servers, depending on the architecture. So make use of the transport map because it allows you to perform these types of mappings to direct traffic. You essentially are able to direct traffic using the transport maps, and we've shown you how to do so. We've pretended that our SUSE box, the SUSE serve box, was the internet gateway relaying traffic for some domains that it doesn't handle locally, including Linux CBT external and these two other domains. But then rather than having the server perform an MX lookup for each message coming into the three domains that we do relay, we can speed up the process by directing traffic explicitly using the transport maps, which saves time and also allows us to precisely tune the delivery of these messages.